Okay, we need to get started. All right, so PS4 is out and consists of two parts, PS4A and PS4B, which you hand in differently. A is continues in the vein of the previous two assignments, so it consists of 5 methods involving searching and optimization loops that you'll be implementing. So that's half of it's 50 points. And the other 50 points is to create a simple animation using the drawing methods we used in the lab a few weeks ago. Now the difference in the way you hand it in is important. So you'll hand in PS4A just by handing in the Java file like you've done all the other assignments. PS4B, you've got to hand in the entire Eclipse project. And the instructions to do it are in the assignment. So I won't repeat them now, but follow those instructions carefully. Don't just hand in one file. You need to basically zip up the project and hand it in, and you need to zip it up the way I ask you to, or it will cause problems. The auto grader for PS4B, all it will do is check to make sure that it looks like you handed in a zipped project. So there's one test case. It's basically seeing if it can find the main method where it expects it. Other than that, there'll be no auto grading of the animations. It'll just be, the TAs will be grading them by hand. Okay, any questions or problems I could help with before we start? Okay, so this is the 5th week of the semester, so after this week, the semester is 1/3 over. We're approaching the time when there's going to be a midterm. So the fall break is early in October. I think it's basically the first full week in October is fall break. And then the midterm will be the week after that. So we still got a few weeks to go, but just keep that in mind. What I want to do is start with today is look at a method from PS3 that you just finished. So here's PS3. So what was the hardest method? Okay, we got get life stage, we've got Cartesian position or find position. I expect those were all fairly straightforward, just involved multi-way ifs. There is to-pig Latin, which converts a word to pig Latin. That's a 3-way if. Convert to pig Latin takes a string of words and turns all of them to pig Latin. There was ContainsAll, which tells us whether every character of the source appears in the target. There were make line and make rectangle, which are similar, and then next hailstone and hailstones. So what do you think is the hardest one? All of them? Yeah.
Make rectangle was probably the hardest one for me.
Okay. We've got to vote for rectangle, so let's try to solve it. So this was all about accumulation loops. So we're given the height of the rectangle and the width of the rectangle. So we've basically got integers to work with. So we're going to be iterating over basically producing one row of the rectangle at a time. So that suggests to me that we need to declare a variable like row. And while row is less than height, and I'm not going to get this quite right yet. We do something and then we say row plus plus. So that's sort of a loop that'll iterate over, it'll produce something for each row. Now, it's an accumulation loop, so we need an accumulation variable. And what type should the accumulation variable be? It needs to be a string, because make rectangle returns a string. And we'll start out being the empty string. And when we're all done, we'll return the rectangle that we've built. Okay, so we sort of got the bones in place. Really, all that's left to do is decide how do we build up the rectangle. Okay, so what is, we're supposed to, let's say the rectangle has, here's a picture, a plus sign and then a bunch of minus signs and then a plus sign. So that's the first row. The last row looks like the same thing, and the rows in between all look the same. So how are we going to produce these individual rows? Yeah?
Is there maybe make line method to produce one?
Okay, so we've got a make line method up here to make lines for us. So let's use it. Okay, so how could we produce the rows that go in the middle? Let's forget about the first row and the last row for the moment. How can we produce the right number of these kind of rows that have vertical bars and spaces? How do we create the right number and glue them all together? Yeah?
In the volume, we use height minus 2. This is practically
Okay, so we don't need height rows, we need height minus 2 rows, because in the loop we're just going to deal with the inner rows. We're not going to deal with the top and the bottom. Okay? So that's a good observation. How do I update, each time through the loop, how do I update my accumulation variable? What do I append to it? I want to, each time through the loop, I'm going to create one line and stick it on the end of that rect variable. Yeah?
the make line method.
All right, so I'll just call make line, and I've got to give it the edge character, which is going to be the vertical bar. I think it's a character I need, right? The space character, which is the inner part, and then how, the width of the thing, which is just width. Now, where'd that width come from? Right? It's a parameter to the method. Rectangle is told the height and the width. So we tell make line every time to make a line that wide. We just take that parameter and pass it right there. And then you notice this if we tested it out, every line needs to end with a new line in our rectangle. So I'll add that on at the end as well. So if we just leave the code like that, what would it produce when we called it? Yeah?
It produce 2 columns of lines, of vertical lines going down without the bottom.
Yeah, so it would produce this part of the rectangle, ignoring the stars in front here, but it would look like he said 2 vertical lines. Now, all we got to do is stick one of these at the beginning and one of these at the end, and we're done. But those 2 things are the same, so let's create one right here. I'll just call it top. How do we create the thing that goes on the top? Same thing, we just call make line, except this time we want a plus, and we want a minus, and we want that to be of the given width, and we want that. Right? So that gives us the top and the bottom, by the way. So what should we return? If we just return rect, we're just getting the inner part of the rectangle. Yeah?
We could, and your string, that's different.
Yeah?
Top plus rect plus top.
Yeah, we just put this at the beginning and the end and return it. So it's a little different from a standard accumulation loop in that we've got to do a little something to that accumulation variable at the end to make it the complete answer. But the thing I want you to take away is this looks just like an accumulation loop, except this little twist. Ignoring this part, this is just code that steps through a sequence of integers. In this case, 0 up to height minus 3. Because they use the less than, not less than or equal. Then I add an accumulation variable, which I return at the end. And then I update the accumulation variable each time through. And this also illustrates the power of having a method that does part of the solution for us. If I didn't have make line, I'd either have to write it or I'd end up with another loop inside this while loop, and then things get really confusing. So this is a lot better way to structure it. Okay, now it's real easy for me to do because I wrote the problem and I've done a lot of problems like this in my life. But your goal ought to be to get to the point where you can take a problem that's described like I did and hone in on it like I did here. Just realize, accumulation loop, I can write the skeleton pretty easily. I had to make an adjustment here. I had to make height -2 instead of height. But I knew I needed an accumulation variable, update in the loop, return the accumulation variable at the end. Okay, any questions about that? All right, let's try one more. Contains all. I guess that one was hard too. Okay, I want to know every character in source, does it belong to target? Okay, so this is an accumulation loop. What are we iterating over? What are we consuming? A scanner, a string, or an integer range? String. This is a string problem. So we know that that's going to look something like this. All right. So there's the skeleton. In fact, let me put a little bit more in here. That's the prototypical enumeration loop for a string. We set up an index, and then we count the index up to one less than the length of the string, and then at each step we can pull a character out and do something with it. First question you have to answer is, are we iterating over source, or are we iterating over target, or are we iterating over both? What's going on here? Do we pull a character at a time out of source, or do we pull it out of target? Or do we somehow want to do both at the same time? Any opinions? Okay?
Target.
Okay? Got one vote for target. Got another vote for source. One of you is right. All right, let's try to finish the sentence. For every character in target, suppose we want to iterate over target. For every character in target, what do? Check to see if it's in source. But what's the problem say to do? It says reports whether or not every character in source occurs at least once in target. It doesn't say everything in target should have some property. It says everything in source should have some property. So at source we want to iterate over. We want to look at every character in the source and make sure that it occurs in target. So we'll replace those question marks with source. Now, I told you this is an accumulation loop. That means we need to add an accumulation variable. We return the accumulation variable at the end, and we update the accumulation variable in the loop. So what type of variable should the accumulation variable be? Boolean. It says right here. That's what the method returns, so we better declare it to be Boolean. I'll call it all in. And I'm going to start it out as true. And right down here I'm going to say return all in. Now, I saw I saw some solutions that were correct, except they set all in to false. So how do you decide whether the initial value of all in should be true or false? There's only two possibilities once you realize it should be a Boolean. Let me propose this. Suppose source is empty. That means this loop doesn't matter. The loop won't run at all if source is empty, because index will never be less than 0. And so what we're going to be doing, what will we return if source is empty, if this is our code? True. Now, is that the right thing to return when the string is empty? Okay, well, should it? does every character in an empty string occur, if suppose source is empty, does every character in that empty string appear in target? Certainly. There aren't any, so. Now, sometimes you get into philosophical arguments about this. But the general rule in logic is that if you're asking, does everything in some set have some property, and the set is empty, the answer is yes. So the right thing to return here is true. And I think there was a test case, actually, that tested what you do when source was empty. If you didn't understand the philosophy behind it, the logic behind it, there's a test case that says that what should happen when source is empty. So if you start out as true, then you're going to get the right return value. So that's evidence that we ought to start with true. Now, all that's left is to update all in here. We've got to combine all in with something to update it. Now, if this were integers, we might be adding something to all in, or multiplying something, or dividing, or whatever. But these are Booleans, so there's really not that many choices. Now, what we want to find out is, we got to find out if C appears in target anywhere. How do you do that? Yeah. You just do target. Right, so we ask it, give me the index of character C in target, and that is going to be -1 if it's not in there. It's going to be greater than or equal to 0 otherwise. So this Boolean expression here will be true if the target contains C, and it's going to be false otherwise. So how do we combine all in and this expression here, which is either true or false? So that's true or false. This is true or false. Yeah?
You use the AND operator.
Right, we just use the AND operator. So let's see what happens. All in starts true. Let's say we come down here and we find out that the first character occurs in target. So that's true. What's all in going to be after we do this AND? True. We go around again. The next character occurs in target. So the highlighted expression is true. This is true. So true and true is true. So all in is true. We go around the loop again. Suppose the third character does not occur in target. So that's false. What's going to happen when we AND true and false? False. All in becomes false. And there's no way for it ever to become true again. Even if all the rest of the characters occur in this target, because all in is false, every time we do false and anything, the answer is going to be false. So when the loop terminates, all in is guaranteed to be false, and we return it. So it'll be true. All in will be true if we get through the loop without finding a character that doesn't belong to target. Otherwise, it'll be false. Now, what if you didn't know about index of? No one has mentioned this little mistake here. What happens if you don't know about index of? Well, what would you have to do? Yeah? Yeah, you'd end up writing either putting a for loop inside the while loop, which I'm telling you is, until you get really solid with loops, you don't want to have doubly nested loops, but you'd have to put some kind of loop inside the while loop to search for the character in target, and you get a mess. Or you write a separate method to do that, but it's best if you know index of exists. Okay. Any questions about that? How many of you did this that way? There are other ways to do it. Did anyone write a loop like that way that accumulated a Boolean and returned it? Not a single person? One person. A few people. Let me show you another way to implement it. It's tempting to implement this as a searching loop. So let's try that. So with a searching loop, the skeleton is the same, but we're not going to have that. Instead, right in here, we're going to have an if. Let me comment this out. If something is the case, we're going to return something. And otherwise, we're going to return something at the end if we don't find it. So another way to do this is to think of the as ContainsAll, this loop, as searching for a character that doesn't occur in target. So if we find a character that doesn't occur in target, we could return right away. What should we return right away? False. Okay? So how do we know if we have found a character that doesn't appear in target? Yeah?
If you do an index of equals -1.
Right. So we just sort of copy this here. And we check to see if it's equal to -1. So if you find something which doesn't belong, we've already said we're going to return false. So we're searching for a character that does not occur in target. If we find it, we return false as our answer. What if we don't find such a character and this loop eventually ends? We return true. So that's what you get when you view this problem as a searching problem. So how many of you wrote something like this? So apparently this is more natural as a searching problem than an accumulation problem, and that's fine. Yeah?
Will you get docked down?
No, you won't get docked. Okay, any other questions? Yeah?
What if we just found a method that does all that for
What do you mean found a method that does all that for you?
contains, dot contains?
Well, there's a method dot contains on strings, but it's not going to tell you, like, if it'll tell you if a large string contains a simpler string as a substring.
Yeah, I just did that character. If it contains this character substring, and then loop through that.
Oh, you use contains instead of index of.
Yeah.
Yeah, well, it's the same sort of thing. You're just, instead of using index of, you're using contains.
Fine.
Yeah, that's fine. I thought you were going to say you found a method that did just what you needed on GitHub. No. Yeah, you don't want to get that and paste it in. Any other questions? Okay. I will get organized soon and post the solutions to this in the previous assignment so you can look at them. Not to say that your code has to look exactly like mine, but it's always good to see sort of a model solution. All right, so next thing I want to talk about is the animation problem. So PS4B, as I mentioned, is the assignment is to create a simple animation. And you may be thinking, what the heck, we haven't talked about animations at all. But what we have talked about drawing things on a graphics context, and that's really all animation is. So let me show you what I mean by that. So first of all, here's an animation, one of the animations I give you as a demo. It is not meant, I'm not saying your animation has to be this involved, although many animations that we get are a lot better than this. Most animations we get aren't as good as this, though, I would say. So you can write an animation that lasts for about 10 seconds. This lasts a little bit longer. And so in the assignment I mentioned that this is not mildly amusing, and so we sort of got a few laughs out of it. It's sort of it tells a story. You can see what's going on. You can tell someone what happened in the animation. It lasted a little over 10 seconds and then stopped. Now, all this stuff that you're seeing, like the reverse button, just runs the animation in reverse. Pause will stop it. That's all given to you. Your job is just to draw what goes in the middle there, in the blank area in the middle. So you're drawing everything in here. Let me show you a simpler animation. So To run the animation, you have to, what you're running, the main method that you care about is in the animation window class, which you're not going to modify, but that's what you have to run. So here's an animation, and if I play it, nothing happens. So that's a really simple animation. So let's make it do something more interesting. So what you have to do is go to the animation class, which is right here, and you've got to implement the paint frame method. So as you know, an animation is just a series of still pictures. So this method, paint frame, is called by the code I'm giving you 33 times a second. So all it's doing is every 33 times a second, it'll call paint frame, it'll say draw me a frame, and it will display it. And then later it'll say draw me the next frame, it'll display it. And it displays them 33 frames a second, and so you get something like an animation. Now, look at the parameters that paint frame takes. This parameter here, graphics 2D, is or G rather, which is a graphics 2D object, is what you draw on. Okay? There was a lab where you used some methods to draw on G. Height and width are the height and width of the area you're drawing on, which is sometimes handy to know. And time is the amount of milliseconds. A millisecond is a thousandth of a second. So the number of milliseconds that have elapsed since the animation began. And that's the most, well, they're all important parameters, but that's a key parameter because you use that to control, you use that to make the frames different. You want to draw a slightly different frame when time is 0 than when time is 300. Let me show you what I mean. Let's draw something. Let's say draw rectangle. And it wants to know the x coordinate, so I'm going to put it at 200, 200, I'll make it 300. So the x coordinate is 200, the y coordinate is 300, and then I'll make its width be 50 and its height be 75. So every time this method is called, what it's going to do is draw a rectangle on a completely blank white background. And then it returns false. The deal is, if you return true, the animation ends. So this animation never ends. So what's it going to look like when I run the animation? If every time this method is asked to give me a frame back, we draw exactly the same frame every time. Yeah? Yeah, it's just going to be a still picture. So there it is. We say play, and nothing moves because we're just drawing the same thing over and over again. That's no fun. Now, you notice the x and y coordinate. X measures, this is the origin up here. It takes a while to get used to this. And so this is the x direction. So the horizontal direction is x, and it increases left to right. The y direction is down, and it increases top to bottom. So when I said draw it at, I think it was 200 over, 300 down, I was telling it this corner of the rectangle. So just keep in mind, you're most likely to think that the origin's down here in the bottom left corner, and that y increases as you go up. No, y increases as you go down. Okay, we need to make this thing move. And so the simplest thing way to make this thing move is, instead of making the horizontal position be 200, what would happen if we made the horizontal position be time? So every time it's called, we draw the same rectangle at the same height, but the spot we draw it depends on how many milliseconds have elapsed. So what effect would you get that way? You'd see it move, right? Time gets bigger and bigger, and so it would, each time it's going to draw it a little further to the right as time increases. So let's try that. Okay, so there's our rectangle initially at x equals 0, and then I click play, and it's gone. How can we slow it down? Just divide time. So let's say I divide time by 100, so it doesn't get big so fast. All right, that's kind of slow, but you get the idea. So you have to play around with it to decide, okay, maybe I divide by 20. Okay. Okay. What if, if you want to start sort of closer to the middle and then move to the right, you could do that. What if you'd like to draw some text? Let's try this. Draw string as a method. And it wants to know an XY coordinate. So let's say we draw it at, let's draw the string. Well, I'm not sure what string I'm going to draw, but let's draw it at 400 and down 50. Okay, let's draw hello. Well, whatever. Okay, here we are. Okay, and you can see hello at the top. It's kind of hard to see it. If you'd like it bigger, I happen to just paste this up here so I wouldn't. We just need to tell G to use a bigger font before we draw it. So I'm using a 60-point font now instead of wherever that was. So if I run it, I get a bigger hello. Now, what if I'd like to draw a different string each time? Here's an easy way to do it. Let's just do this string. Whatever time is, we'll convert it to a string. We'll append it to the empty string and draw it. So what's that going to look like when we draw it? It's just going to follow along with this time up here, except this is in seconds and this is going to be in milliseconds. So let's do it. You know, if I pause at any point, you can see it says 3.27. It was actually 3,269 milliseconds as opposed to 3.27 seconds. Yeah?
Is there a way to do it where you have a string, like it draws a string and then after a certain amount of time it disappears?
Okay. What if we want the string to disappear after a second? That's when you use ifs. So if you want something to change, if you want something to behave one way for a while and then another way for later, use an if. So let's say, what I do this, I would say if time is less than 1,000, we do this. So now, it should disappear after a second. It's only going to draw it for a second. And it disappears. It's not drawing it thereafter. What if you'd like it to appear for a second, disappear for a second? Appear for a second, disappear for a second. Okay? We can do something like we're going to take time, we're going to divide it by 1,000, so that's now seconds. So it's going to be 0 second, 1 second, 2 seconds. And then we're going to take it mod 2. So now it's going to be, taking it mod 2, it's either going to be 0 or 1. It's going to, the first second it'll be 0, then it'll be 1, then it'll be 0 again. And then we're going to ask, wow, that's only display if this is equal to 0. So now, it's going to go off, and it's going to come back on, and it's going to go off, it's going to come back on. What if we would like the rectangle to, right now it's just a black rectangle, the outline of a rectangle. There's also a method called fillRect, which will do this. It just draws the whole thing. What if after 3 seconds we would like it to start moving the other way? What should I do? Yeah. Say a little louder. All right, use an if statement again. So I say if time is less than 3,000, do what we're doing before. By the way, do you notice that I take the time to make sure stuff is indented as I'm working? Okay, you should get in that habit as well. It's not like you don't just program and then indent at the last minute so you won't lose points. Get used to keeping your code nicely indented because it makes it easier to find certain kinds of problems. So what should I do when it's no longer less than, it's 3 seconds have elapsed? If I want it to turn around and go backwards. Okay, let's try minus. All right, let's run it and see. So we go, let's see, we're still 2, 3, oh. What went wrong? See, the problem is, where was it? What was the x-coordinate after 3 seconds? Well, this was 3,000. Divide that by 20. Is that 150? Okay, so it was at position 350. But then we jumped it back to 200 and started moving it to the left. So what should we do to fix this? Given that at the point it turns around, it's going to be at location 350 if I figure this out right. 3,000 divided by 20 is 150. What do I change down here so that it... Right, you would change this 200 to 350 because that's where it is when the time clicks over. So let's try that again. That didn't work.
You have to add 250 because 7550.
You did that expression, it's gonna be 200.
Oh, okay, I got to add, well, 550?
Yeah.
Okay. If you can't figure it out, you just can experiment. Not perfect, but anyway, you get the idea. Or, well, so you can use ifs to control changes in behavior. Now, suppose you make a complicated thing and you want 2 of them. So we have, let's call this a complicated thing. This is a box that moves in one direction and then goes back the other way. Suppose we'd like 2 of them. Or 10 of them. What would you do? Yeah?
Do we want 10 of them all at once or 10 of them?
I don't know. I just like to be able to create them at will. Yeah? Right, create a method. So what I'm going to do here is I'm going to copy this. I'm going to come down here and make a method. In fact, there's this neat little thing in Java, in Eclipse, I'm going to try here. So I'm going to go to Refactor, Extract Method. So you highlight a block of code and click Extract Method. It'll ask you for a method name, and I'm going to call it Draw Reversing Box. And what it does is it replaces that highlighted code with a method called to draw reversing box, and it passes in G and time to it, and then it writes the method for you. Okay? So now instead of doing this code up in the original method, we're doing it here and just calling the method draw reversing box down here. So first let's make sure this works right. Okay? And now I would like to do 2. Well, that's not going to work too well because they'll just be right on top of each other. So we'd really like to have more parameters. Besides graphics and time, it would be nice to do, let's take a passive parameter, which is the time at which you reverse. So we'll call it reverse time. Okay, so rather than it being 3,000, let's make that reverse time. And up here, we'll need to pass in the 3,000. Okay, while we're at it, let's pass in x and y. So down here, we're going to use x and y. And this is going to be something like x plus 350, I think. I don't know. And instead of this, it's going to be y. And then up here, we need to pass in x and y. So we'll pass in 200 and 300. So let's see how well this works. Let's make sure I didn't make any mistakes. So it's still working like before. And it reverses. So what did I buy? And this is more complicated now. I've got this method here that I'm calling. Had to add parameters and all this stuff. What's the payoff? All right, I can do more than one. So I'm going to just make, now if I want more than one, I just call the method. Let's have it reverse after 2,000 seconds. And let's start this at 50, 50. And I think I still got some work to do to make this really work out, but you'll see it move. And it jumps. We're not quite calculating the turnaround position quite right. But now, you know, we can, let's pass in color. Import color. Down here we just got to do this, g.setColor to color. That'll make it color the box any particular color. And up here we just got to pass in a color like color.red and color.blue. Now we got two different colored boxes that we can control. So when I say in the assignment write-up that you can exploit methods to make things simpler, that's what I mean. If you get some code that does some neat effect and you want to replicate it, you know, abstract that code into a method, make a lot of things parameters to it, and then you can customize it to your heart's content and make multiple versions of them. Yeah?
To get the position right, wouldn't you just like divide by 20, or time by 20, and then multiply by 2?
For what?
To get the position of the reverse.
You mean right up here?
Down in the draw reverse.
Oh, you're trying to fix my bug down here?
Yeah, so you see those three things?
Yeah. I'll just leave that as an exercise for the user here, for the reader. It's hard for me to solve problems while I'm talking. So. Okay, yeah.
If you want something to accelerate, could you use like math.pal?
Yeah. He's asking about using math.pal to accelerate. That would really accelerate because it depends on your curve. If you want something to move in a circle, you can use cosine and sine. So if you compute, roughly, if you make the x-coordinate be something like the cosine of time, divided appropriately, and the y-coordinate to be the sine of time, you can get it moving in a circle. Okay? Now, do you need while loops? People look at this problem and think, certainly there has to be a while loop somewhere, some sort of loop, because we're doing something over and over again. But you don't, if you find yourself writing a while loop, you're doing it wrong. Why is it you don't have to write any while loops? Yeah?
If you write something while time is less than or like equal to some other time, when you open up the program, it's going, since the time is less than when it's created, than whatever you put in. So you end up creating an infinite loop that can't really open, at least in my experience with it.
But, okay, let's back up to something more basic. How does this program get away without a loop? Yeah?
There's already a loop that calls draw reverse and
Right.
blocks over and over.
I wrote the loop. My code calls paint frame, whatever this is called, 33 times a second. That's the looping. So you don't have to worry about looping. You just have to worry about, you just say, what time is it? Draw the frame that's appropriate for that time. And the animation appears. Yeah?
So the animation that you presented before us, you showed arcing over.
Yeah.
And if that, and then the ball basically moves maybe from say point A to point B in 1 second. It still has to fill the in between frames, or else it will just feel like it will teleport over there. So wouldn't it be better to make a while loop for that small iteration?
No, because
Implemented by maybe 0.50 or something.
no, like when my stuff is arcing, I'm just using the equations for a ballistic trajectory of a cannonball. And depending on time, I am calculating its xy coordinate at that time just by plugging time into the two parameterized equations. And just draw that at discrete points. There's really no need for a while. Yeah?
So I know in Java they have something that generates a random integer. Is there anything where you could have it generate random colors?
Random colors?
Yeah. Or would you
Yeah.
be changing
So
the color?
there are a variety of constructors you can look at for color. And one of them, I believe, takes an int as a parameter. So you could experiment with creating a random int and using that for the constructor. Something like that. Okay? So, you know, you're supposed to have fun with this assignment, and I often find the students just are too grim about it. So just get some simple idea of some simple animation you want. It doesn't have to, you know, if you look at the demos that I gave you, those are the very best from one year. And there's always people in the class that are artistic. I'm sure a lot of you are artistic, and they really go overtime making a really impressive animation. That's fine, you know, but you don't have to do that to get a perfect score. Just I sort of explain in the assignment what I want to see. So just have fun with it. Yeah.
Is there a way to change the background of the window?
Okay, he's asking, is there a way to change the background of the window? The way to change the background is, first thing you can do is just paint a huge rectangle that covers the background. Now, some students get really, they want to go and change the code that I gave them, because there's some things you can't do just in the method I gave you that you'd like to change globally in the other two files that I gave you. If you're that intrepid and want to do it, that's fine. That's why I'm asking that you hand in the entire project instead of just this file, because some of you may want to go in and monkey around with my code. I don't object to that, but most of you don't need to even look at it if you don't care. Okay, but have fun with it. Don't think it's not. I'm not doing this to punish you or anything. It's just sort of a break from writing another method library. You're doing something creative. You're writing a complete program. You know, something you can run. You're not going to show your grandmother your method library, but you might show your grandmother your animation. So that's just what I'm thinking. Okay. All right, let's take a break for a few minutes and we'll do something different. Okay, so I had a conversation there at the break. I want to remind you, if you go into GradeScope, so PS1 and 2 have been graded. We're grading PS3 currently. If you go into GradeScope, you can see the rubric we use for grading. You can see where you lost points, if you lost any points. And if you go actually look at the code as it exists on GradeScope, there may be places where the TA put comments. They'll be pretty easy to see. they can add comments in explaining maybe ways to improve your program or why they deducted points. So do have a look. Just don't say, oh, I got a 98, I don't know why I lost 2 points. You can go find out why. And if we made a mistake, you can ask that it be corrected, again, through GradeScope. Okay. We're going to talk about a new thing, arrays. So this is a new kind of object. So we've looked at strings and scanners and fonts and graphics and all kinds of objects, big integers. Now we're going to look at a type of object called an array. Now, the thing about arrays that's odd about arrays, they are built directly into Java. There is no array class. And it has very different syntax from what you'll see with other objects. So it's a sort of a fundamental thing in the programming language. So you can think of an array as a fixed length list. So if you need to make a list and you know it's not going to grow or shrink, that's what arrays are for. So they're think of them as fixed length lists. They're built directly into Java. So it's not defined. There are no, you're not going to find constructors and methods. When you create an array, you declare the type of element it can hold. So you can have arrays of ints, or arrays of scanners, or arrays of strings. And when you think about arrays, think about it the way this diagram here shows. This is meant to be an array of 5 integers. So this is an array that contains the integers 32, 16, 34, 10, and 66. And the numbers down below, 0, 1, 2, 3, 4, those are the indexes into the array. So you can, if you ask what's index 0, it'll tell you 32. If you ask what's at index 3, it'll say 10. You can change what's stored at a given index. So that's the basics of an array. That's how you think about arrays. So let's look at what the code actually looks like. So that's how you declare an array. So if you want to have a variable A which can hold arrays of strings, you use this first method up here. You say string followed by square brackets. So that's you have a type name followed by square brackets. That says I want an array of the type. So that says array of string. This says array of ints. Or you can think of it as string array, int array. And then we got a variable A, a variable B. A is going to be holding a string array, B is holding an int array. That's how you declare. Here's how you create. So you use new just like you would with scanners or what have you. But the way you create it is you say new string and then in square brackets 20. That creates a new string array of length 20. Or a new int array of length 25. So when you create the array, you got to say how long it is. Arrays don't grow or shrink. They're always whatever length you give when you create them. So that's how you declare them. That's how you create them. Right? This is how you get something out of an array. So that's A sub 6. You're saying, give me the the string. Give me the string that's stored at index 6. Remember, the indexing starts at 0. This is how you change. So that says store the string hello at index 5 of the array, A. And this is how you find the length. You just do a.length. Very confusing at first because you kind of want to put parentheses after the length, but it's not really a method. It's just how you find the length of an array. Okay? So that's the fundamentals. Declaration, creation, access, modification, length. Right? We need to see them in action before you really understand them, but I wanted to show you all this up front. Okay? For loops, which you've been reading about, but I haven't used in class, are commonly used for iterating over the indexes into an array, or honestly, for lots of other kinds of loops. And this is what it looks like. So the way a for loop works is it has the keyword for. This is executed exactly once before the loop runs. This is the test that determines each time around whether the loop should continue. And this is done at the end of each repetition to update. So that is equivalent to this while loop. So that int I equals 0 that's in the for loop here shows up here. This condition becomes a condition that controls the while. Then we have the statements at the while loop, and after the last statement, we do the I++. And there's sort of some fine print here which says that while loop is only equivalent if none of those statements are continuous statements. Now, I think I've had you read about continuous statements, but I haven't talked about them. So we'll leave that aside. So in the absence of continuous statements, these are equivalent. Now, why did I put this whole construct inside a set of braces? That's very subtle. Well, what's the difference? What if I just took this brace here away and this brace here away? Why would that not be equivalent to that for loop over there? He said because int I is outside the loop. Right. This int I is private to the loop. You cannot use I down here below the loop. If I didn't have these braces around, after I declare int I would be visible after the while loop. I don't want that. So I constrain the scope of that I by putting these braces in. That's a fine point, but it's important to get right. Now, why would you write a for loop instead of a while loop? If you can turn one into the other. Yeah.
You save a lot of time on lines, and
Save time with what?
you actually don't have to type as much when you save a lot of lines. So.
That's one argument for it. It's more compact. Okay. What's another reason you might want to use a for loop? Yeah.
Give a certain length.
Well, it's often used when you know how many times, you're going to be iterating a fixed number of times, but it doesn't have to be. You can turn any while loop into a for loop and vice versa. Yeah?
To keep things more readable.
Keep things more readable. Okay, so the nice thing about a for loop is the stuff that controls the loop is right at the top. You've got the initializer, the condition, and the incrementer, or whatever you want to think about it, all in one place, separated by semicolons up there at the top. You don't have to, the while loop, you sure got to search around for the important parts. But it is totally a matter of taste. Some people want to write everything as a for loop. Some people prefer to write everything as a while loop. I tend to go back and forth depending on what I'm doing at the time, or what just looks better to me. But it is a matter of taste. So it's not like you can't say it's wrong to use a while loop. You should be using a for loop. You might say, I think it looks better if you use a for loop, or I think it looks better if you use a while loop, but someone might disagree with you. So it's not a hard and fast rule. But so if that's the case, why do I teach you about for loops? Why don't I just say, just use while loops? It makes life simpler. There's only one kind of loop. Just use while loops. Yeah?
So you can pick what you want to do.
Well, so you can pick what you want to do, but I could just take the attitude, I don't want you to pick, I want you to do what I say. Don't use for loops. Why would I be doing you a disservice if I said never, don't even think about for loops? How would I be handicapping your future? Yeah.
Someday you have to read a program
Yeah.
someone else made and it has a for loop and you don't know how it works.
Right. Maybe you think while loops are the most beautiful thing ever, and you're never going to sell your program with a for loop. You're going to read programs with for loops. Then it can work in the opposite. There are other kinds of loops in Java. You need to be familiar with them even if you don't use them, because you're going to read them. Okay. So with that out of the way, let's look at some examples of arrays in action. So I have an arrays package in arraydemo.java. So let's start with this first one here, print array. So the idea is we get an array of strings, and I'm going to print each element in the string out on one line. Okay? Pretty simple. So that's basically an enumeration loop. But I'm going to do it with a for loop. So to do a for loop, I'm going to do this. For int I equals 0, I is less than, so I'm not typing well today, strings.length, I++. Or if you don't like that, you can say I equals I plus 1. but people might make fun of you, so you should do I++. So that just gets it all out of the way. That's the skeleton of an enumeration loop over an array if you type it as a for loop. Now all you got to do is say what the loop should do each time through. And what is it we want to do each time through? I said I wanted to print one on a line, so each one on a line, so what should I do? I should print line. That's clear. How do I get element I to print from the strings array? Okay, string, someone's back there doing something with hands, but well, that didn't work. String sub I. So each time through the loop, it'll grab element I out. I keeps changing as the loop runs, and we print it out. So that'll print every element of the array on a separate line. So pretty simple stuff. What would it look like if instead of having an array of strings, we had a string, and we wanted to print each character on a separate line? How would this loop look any different? Yeah, we'd be using char at instead of the square bracket I notation to pull a character out. But the skeleton of the for loop would look the same. I do. Thank you. Okay, good. Let's see how I use it up here. Look in main here. I've been putting this off for 4 weeks. I never explained what that parameter to main was. Well, what is that parameter to main? An array of strings. So when main is run, it receives a parameter, which is an array of strings. And it's called args. Now, we've been ignoring that array of strings, and you may be wondering, what's in the array of strings? Where does it come from? So let me give you a quick explanation of where it comes from. Args, that array is called the command line parameters. And it's not going to make any sense to you unless you've ever run something from a command shell. Surely in your life you've opened up a command shell and done something in it. Maybe not. Used to be the only way to use a computer. I'm going to right click on this project and I'm going to say show in local terminal. And so what it does is it opens this terminal down here, and I'm connected. This is just a terminal window that's connected to the folder that holds the project we're working on. Now, if I cd into the bin directory, and I can do ls, which show you. Well, I'm not using Unix. I do dir. And I see there's an animation folder, an animation demo folder, arrays folder, and CS1410 folder. Those are just the packages. If I ask what's in the animation folder, it's going to show me the class files that got translated from the code we wrote. I'm interested in the arrays folder. And there's my compiled array demo program. Now I'm going to run it from the command line. So the way to run it is you say Java, then the package name was arrays, .array demo. And it'll run the program and display the results here in the console. So I'll do it. And it crashes because we haven't implemented some method down below. Okay? But that's called running a program from the command line. Now back up to the code. Let's see what's happening here. First thing we do is we print out the command line arguments. And let me change this slightly. We're going to print it out. I'm going to print this out. So we can tell it's happened. So let's come down here again and run it. So what can you say about the array that our main is getting as a parameter when I run it from the command line here? What's the length of the array? 27. No, don't look at the exception there. The exception occurs later after the. Remind me what's happening is we print out We're calling our print array method on this array. It's going to print everything in the array on a separate line. And then we print this right here. So what happens is we ran our program, it immediately printed those 3 dashes. Why didn't it print out any command line parameters? The answer is obvious. There aren't any. The array is empty. There was nothing to print. But if I ran it this way, if I say run it, and by the way, pass these 5 parameters in, A, B, C, D, E, I hit enter. Main gets an array containing A, B, C, D, E. They're called command line parameters because they're parameters that you add when you run the program from the command line. Okay? So, are they only of interest if you're running the program from the command line? If you ever write a script that calls a Java program, it can pass parameters into the main the same way here. If you stick to Eclipse and you want to find out what happens, what you have to do is go to arraydemo.java, and I want to go to run as. I'm going to go to the run configurations, and somewhere in here, arguments, I can type hello world. So what you're doing is saying when you run, wait, not animation window, array demo. When you run an array demo, pass hello world as the command line parameters, and then I run it, and you can see it printed out hello world. So you can set command line parameters when you run it from Eclipse as well. Anyway, long-winded way of explaining what this is. These are the parameters that were provided to the main when it started running, and there are various ways to provide them. Okay, let's make another array down here. I have a method called makeRandomArray, and it's supposed to create an array of length n containing randomly chosen integers between 0 and 9999 inclusive. Okay? How do we do that? First of all, how can I create an array of length n? What do I type to create an array of ints of length n? Yeah?
If I remember correctly, the int of the
Well, okay, you're declaring a variable. Let's just create the array first before we store it anywhere. We'll create a new array. So first thing we type is new. And remember how we create a new int array of length n. Int. So that creates a new array of length n. Then we got to store it in a variable. Let's call it random ints. And we need to declare random ints. So how do we say that random int is an array of ints? Okay, so what we've done is we have created a new array of length n, and we're storing it in a variable called random ints, which is an array of ints. Very good. You know, what happens if we do this? What do you suppose that error message is going to say? It's going to say type mismatch, cannot convert an array of ints into an array of strings. So that needs to match up. Okay, great. Now, let's just write a for loop to store 0 in every element of this array. So what would that for loop look like? So for, and this gets pretty automatic. We can have an index variable, which I'm going to call I, because that's what people call index variables. We'll start at 0. At what point should we stop? How long, what's the last value, how do we know when this loop should stop? So we continue while I is less than random ints.length, and we increment by 1 each time. And then how are we going to store 0 at every spot in the array? Or more to the point, how do we store 0 at index I of the array? How do you store something into an array? Do you remember that little bit from the slide? we say random int sub I gets 0. So that stores a 0 into random int sub I, and then we return random ints. So we have make random array. So up here we're going to call it and then do some stuff with it. We're going to sort it and print it out. So let's see how that works. So we sorted it and printed it out. We got all zeros. Okay? What would it take to store random ints in there? What do I have to change right here? So instead of storing 0, I'm storing a randomly chosen int. Yeah? Okay, math.random. So the way to use that, you create a random number generator object. So math.random is one way. This is another way. So that's java.util.random. So it's a random generator class. And then down here, instead of storing 0, we can say rand.nextInt. And the next int is going to be non-negative, but we can also ask it to be less than 10,000. So that'll give us a number from 0 to 9999, chosen randomly. And if I run it once, I get those ints, 1399 and so on. If I run it again, I get different ints. But each time I get the same number of ints because that parameter n isn't changing. Okay? So that's an example of an array. Yeah?
What are the pros and cons of using the Java utility random int generator versus math.random?
Yeah, I think math.random returns a double, if I'm not mistaken. And maybe a random double, then you got to, this way, there are more methods on the random number generator object. You can create integers in a certain range, you can create doubles, you can create random booleans. Okay, very good. So, we saw how to print an array, we wrote code to do that. Let's look at this. Down here is where we call make random array. Well, actually, let me point this out before we go on. There is a class called arrays, and it contains a bunch of static methods that do interesting things with arrays. And one thing it'll do is sort them. So we have this array of integers. I call arrays.sort, pass it the integers, and it put them into ascending order. That's why this is always the smallest, and this is always the largest. Then there's a method called toString that'll take an array of integers and turn it into this format, square bracket, elements separated by commas, toString. So arrays.toString will take an array and give you a printable version back. What's weird about this method call right here? It takes 9 parameters, right? What if I wanted to take the average not of 9 parameters, but of 10? Or 11? Or 12? How can you write this method, which apparently will take a variable number of parameters? Yeah? Okay, has something to do with arrays, that is true. So let me show you this little trick. Let's look at average. Look at the header there. Tell me what you see that you've never seen before. The ... part. So you can, the last parameter, you can make ... this way. So what this is saying is, there has to be one parameter, and that's first. So the first parameter has to be a double, and that's stored in first. The rest of the parameters need to all be doubles, and they are collected together into an array inside this method. So down here in average, rest is just going to be an array of doubles. But for the person that's using the method, they don't have to fool with arrays. They just give a bunch of doubles. In this case, those ints also work as doubles. This will be first down in that method below, and there'll be an array of these, which is rest. Now, why don't I just get rid of this and just say that? Why did I do it this way? Yeah? No, this way, oops. If I take this out, well, first of all, how many parameters can you call average with? If you're a user of average, can you pass just a single double to average? Oh, yes, you can. Double would be that first would be the double, the single double. Rest would be an empty array. Can you pass 100 parameters to average? Yes. The first parameter would be first. The rest would be in an array. Can you pass no parameters to average? No, because this right here says there absolutely has to be a first parameter. If I take this out, you would be able to pass no parameters to average. But that's a problem. How do you compute the average of no doubles? So I insist there be at least one double. Let's implement this now, and just Java's going to make sure that rest is actually an array of doubles down here. So how am I going to compute the average of all these numbers? I'm going to compute the average of the double that's sitting in first and all the doubles that are in that array called rest. What's the first thing I have to do to compute an average? All right, I've got to add them all up. That sounds like an accumulation loop, right? So let's write the bones of an accumulation loop. Okay. What's our accumulation variable going to be? No, we're not going to accumulate. We're just adding them all up. So what would be a good name for an accumulation variable for adding them all up? Sure. And what should we start it out as? Okay, we'll start at 0. Each time through the loop, we want to add in one of those numbers in that array rest. So we're going to say sum equals sum plus rest. How do I get element I out of rest? All right, we'll take element I out of rest. Good. Then I got to return the average. How do I compute and return the average?
Sum divided by rest dot length.
Okay, that's close. That would return the average of all the numbers in rest. But I won't also include first in this. So sum plus first is our overall sum. And what do we divide by? I divide by rest.length plus 1. So now when I run it, I get an average of 5 when I average those numbers, whatever they were, from 1 to 9. Yeah?
Could we also have just initialized the double sum as first?
Yep, we could have done this. And remember, first is just there to prevent someone calling this method with no parameters, in which case we'd be dividing by 0. Okay. So a point I want to make here is that there are plenty of places in the API where what you call a method and what you get back is an array. The example I didn't have time to do was a method. There's a method you can call. You can say, here is a folder. Give me a list of everything in the folder. And what comes back is an array of information about everything in that folder. So when you see that square bracket notation in the API, you'll know what it is. You're getting back an array. We're done.